Hi, this is Gio from Core. Did you want to learn about perimeter? Look at the board with my hair. So, let's do it. Let's learn about perimeter. And remember, like everything else, it builds up. So, we must achieve mastery of these skills to be able to work ourselves up to more complex problems. Here we go. My trusty board is not with that one. Okay, let's pick blue. So let's say that we have, in my mind, this is a perfect square. Oh, look at that. And this one looks a little bit more like a rectangle. So let's say that this is 6 centimeters and 5 centimeters. The measurements, also called labels, are very important. We must always include our labels. Alrighty then. So, the perimeter is the outline of a shape. Perimeter equals outline. And the area equals the inside measurement. All right, so these are parallel lines. Parallel lines are one next to each other, and they continue, and they never meet. And in this case, we have parallel lines here and parallel lines here, and that tells us that we can say that this side, the opposite side of this shape, is also 6 centimeters, and this side is 5 centimeters. All right, so if we had to figure out the outline, the perimeter of this shape, what do you think we would do? Did you say add? Because if you said add, you're absolutely correct. It's 6 plus 6 plus 5 plus 5. And 6 and 6 is 12, and 5 and 5 is 10, and 10 plus 12, 22. 22 centimeters. So the perimeter that we're going to represent, let's change colors. We're going to represent the perimeter with a P. We know it's 22 centimeters. Now, area is always represented, it's squared. When we get the measurement of the area, it's always squared. And do you wonder why that is? Yeah, let's figure it out. So if this rectangle is 6 centimeters long, let's do one, maybe I should do the center here, let's see. Is that about 1, 2, 3, 4? All right, remember that in these videos we use a little bit of our imagination. We're gonna pretend that these are very well proportioned. And I think that what happened there is that we had two. All right, let's try that again. My board and I, we have issues sometimes. There we go. All right, 1, 2, 3, 4, 5, and 6. All right, I'm gonna try that again. Let's do it with a pretty color of yellow. All right, I'm gonna start this line right here. Why are you doing that? Oh, guys, this board and I. All right, one more time. The students in Olean always laugh because the board mocks me. All right, this time, even if we get that weird triangle, I'm leaving it. We'll use imagination. All right, so this line here, I'm just gonna go for it. 1, 2, 3, 4, 5, and 6. Okay, so each one of them represents, and of course, we're using imagination, 1 centimeter. 1, 2, 3, 4, 5, 6. That is the measurement going down. Now the measurement going sideways would be 1, 2, 3, 4, and 5. So when we're measuring area, we're measuring it in squares. And it's so much easier this way. So say that you wanted to tile a room and you need to find out what the area is so you know how many tiles you need to buy. Well, if it already has tiles, I guess you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, 21, 22, 23, 24, 25, 30. We could do that, but there's a really, really easy way. And there's a rule for it. And it says that to calculate area, you do the length times the width, and that equals the area squared. No? Okay. But instead of counting all of this, we're going to go ahead and use this formula. And it says, let's multiply the length times the width. Let's see if that works. How many squares did we say were there already? We had said there were 30. So 6 times 5. Well, would you look at that? That is 30. So your answer is your area equals 30 centimeters. And don't forget to square it because it's all about the squares when it comes to area. Okay, how is that? Should we bring it up a notch?